So today we shall be discussing about the energy stored in the capacitor, or we can say when we charge the capacitor we do have to some work, and that work obviously done by somebody from outside gets stored as the energy of a capacitor, or we say the capacitor is now getting charged or got charged. Okay, so some work, as I told, has to be done. So how much is that work, or how much will be its potential energy or stored energy in the capacitor, that we shall be discussing, or going for the expression for that. Okay, so dear all, gets focused on this is topic is energy of a capacitor, right? First imagine we have two plates. I'm talking about parallel plate capacitor. As in the last video we discussed about the capacitance of a parallel plate capacitor. The capacitor is simply a combination of a positive and negative plate, or two conductors having equal and opposite charges. If D is the separation between the plates and capital A is the area of each plate, and that is this plus sigma, that is minus sigma, the charge densities of the plates, right? So initially, now see what happens. Initially, when the conductors or even these two plates are not charged, so we simply transfer electrons or negative charge from this plate to that plate. Okay, you know why electrons, one little question arises, because why is it electron being getting charged, transferred? So obviously electrons are the free electrons are the least bound by the atoms, or they can be transferred from one to other places, because when the conductors are being charged either whatsoever way, does not matter, only electrons can be transferred, no protons can be transferred, because they are bound to the strongest body, that is in nucleus. So protons can never be shifted from one to any other body. Okay, so electrons, one electron has been taken out and shifted to this, and similarly this body acquires a negative charge and this body acquires a positive charge. Now simultaneously what happens when you transfer one electron, or suppose 1 coulomb of electron from this to that body? So this is now negatively charged and this is positively charged. Okay, now if you further want to transfer electron from this to that body, now this negatively charged body will oppose you, obviously, because negative charges will be repelled by this negatively charged plate. So at every further moment you have to do some more and more work, even if you are shifting the charge by equal amount. Why? Because this is getting more and more charges. So for any next 1 coulomb of charges, this plate will oppose by more amount of forces. That is the simple theory. This is very basic, related to the first chapter. Okay, so now we assume that for any intermediate state, this body has acquired plus q charge, so this has acquired minus q charge. If C is the capacitance, C is the capacitance of this parallel plate capacitor, and right now, because you cannot change the capacitance, that is decided by the manufacturer. Okay, so a bottle has a fixed capacity of 1 liter, you cannot increase that unless until you cut it. So that's not the part of the scene. We are simply supposing that it has a fixed capacitance. So if plus q and minus q are the charge at any intermediate state on the both of the plates, then potential between the plates V is equal to how much? The charge over its capacitance. That is simple law or simple equation. So this is the potential by which the two plates are standing at. Now you decide to take very small plus q from from this minus q of minus dq of charge from this plate to that plate. You want to shift that amount of charge. Then obviously you should or you will have to do some work. So a small work to be done in moving dq charge, because now we are at an intermediate stage, so we are talking about any small amount of charge, that is dq of the charge. Okay. Now what will be the work done by the external body, either you or me or any charger? So a small work done, that is dw, is equal to the potential between the plates multiplied by the charge being shifted, that is dq. So that is q over c and dq. This is the intermediate, at any intermediate state, small amount of work done, right? Now initially the conductor had how much of charge? 0, and you want to charge it up to suppose plus q, and your charge is from 0 to plus q. So how much will be the total work done? That will be calculated by integration simply. So I should be doing some little more mathematical calculation. This is not as hard as to develop a cosmological equation, which is supposed to be the hardest of many subjects. Okay, now total work done in rising its potential from 0 to V, in rising its potential from 0 to V, that is final potential, and this was an intermediate potential, so you can take a small v, does not matter. Or how much was the charge? Initially it was 0 and finally it got to be plus q. So in that case the total work done will be equal to d of w, that is integration of this equation q upon c and dq, and the limit will be from, because remember this integration is being done with respect to the charge, so we are setting our limits in terms of charge, that is initially the charge was 0 and finally the charge was capital Q. So C is constant because it will be constant for any conductor, not for all. C, and that is Q and dq 0 to plus q and 1 over c, and this q dq is like x dx, and it is equal to x square by 2. Okay, now if it is 0 to capital X, then we put what? 0 to capital X. The same way you have to do this. You haven't done this. That is q square upon 2, 0 to capital Q is equal to 1 by 2 is taken out c, and that is upper limit minus lower limit, that is q square over 2c. So it is done. This is the total work done by some external agent to charge the capacitor from where? 0 to capital Q. And as per the definition, this work done is called the energy or potential energy or electrostatic energy of this device. So literally we have to write again, that is this work done gets stored as its potential energy capital U. Okay, I am using symbols, please note this. So U is equal to capital total charge square over 2c. This is the final expression. Now we shall split this equation into two more components. That is, we know that Q is equal to C into V, that is capacitance into voltage. So the energy, total energy is equal to C square V square over twice C. One C is cancelled out, that is half C V square. Getting? These are simple. This is one more formula of this, or in the form of CV square. Now we shall remove this C. So again, as C is equal to charge over V, so the potential energy U is equal to Q square over 2 into Q, and this V goes up. So Q is equal to, that is half Q and V. So that these are the three expression for the potential energy. Okay, so this is the target completed or acquired, that is the expression for the potential energy of a electrostatic potential energy in the form of electrostatic and of a parallel plate capacitor. Okay, so please note this down.